Okay, move that out of the way. All right. So this is the DQ for today, or for this week. Use min, max, median, average, standard deviation, P, dot P, uh, range of functions, additional practice with autofill. A little background. So before data is the measure of E. coli per milliliter of water from a well. The after measurement is the same, but made after treatment with an antibiotic agent. If the well water improved, we expect that there would be less E. coli after treatment. So that improvement equals after minus before would be negative. For example, if after minus before on well 1 was negative 10, then there are 10 fewer E. coli per milliliter than there were before the treatment. This means it's making a difference. Okay, so let's go in here. Name. And autofills, there we go. So I know I'm doing before minus or after minus before. It even says that right here. So equals my after cell minus my before cell. And then I'm going to pull it down. I'm just going to double click. That should do it all the way down. There we go. How many are there? 117. Okay. There they all are. Looks like I see a bunch of negatives, but you can't make a judgment on that. There's also this one cell. Look at that. That well did not change. That sucks. All right. We're going to do a mean, and mean is sample arithmetic mean. So that is an average. So equals average. And this is for my before data. So that means it's from here all the way down. There we go. Close my parenthesis, hit enter. Okay. So my mean before was 30 E. coli per milliliter. My median is the middle. So we're actually going to use, and remember from here, it tells us there's a min, a max, a median, an average, and a standard deviation. We're going to use median here. So this is 4 to 120. Okay. So I'm going to do equal median, open my parenthesis. I'm going to do D4 colon D120, just so I can just throw it in there. It does select all the same data. The middle data point was 29. Standard deviation equals STDEV dot P. And again, you could click on it. I'm typing everything. D4, D120, close my parenthesis, bam. Format each value as a number to 2 decimal places. I'm going to format them all right now. Number, 2 decimal places, done. Okay. And then my range. My range would be whatever the maximum value is in that set to the minimum value. So I'm going to go ahead and use the max function, parenthesis, D4 colon D120. Oops, I did something I wasn't supposed to, a tilde. 120. And then I close that parenthesis. That's my maximum value. I'm going to minus my minimum value, min, open my parenthesis. And again, same data set. It's not like I'm looking for some different, oops, D 120, some different data. I want to keep things in the same place. So now I'm looking for the maximum of that data minus the minimum of that data, and that should be my range. And there we have it. And because I built these wonderful formulas, I get to save myself some hassle and I get to just drag them over. Now this will, instead of being, these were column D, instead of being column D, this will be column E, which is my after column right there. And this will be column F, which is my improvement column, which is exactly what I wanted. Looks like it improved about 10 E. coli per milliliter. My median of the improvement was about 10 E. coli per milliliter. And for the improvement data, we're going to use the built-in function to calculate the following percentiles. Format each value as a number with 2 decimal places. So again, we're just following what they say, and we're going to use the percentile function here. Your values might be different here, right? Like mine is 16th and 84th. We don't often use the percentile function, but we're going to go ahead and do it. This would be equal percent, and we're just going to use flat percentile. Sure, yeah, flat percentile. That's what we'll do. Okay, and so the array is, what are we looking for? So this would be this column, but I know that's F, so I'm just going to go ahead and type F4 colon F120. That selects all of that data. I'm going to put a comma in, and then I want the 16th percentile. So that would be 0.16 16th. I'm going to close that percentile, or close that first parenthesis and hit enter. And there we go. And I want to do the same thing here. So I will. We're going to equal percentile. This time I just wrote the whole thing out. I put my parenthesis, F4 colon F120, comma, and this one's the 84th, so 0.84. Okay, 84th. Close my parenthesis and hit enter. And there we go. So there I have the 16th and 84th percentile. And this is 68%, but we can also use the empirical rule. So we use calculations above and the empirical rule to calculate the upper and lower percentile. So that's going to be next. We're going to try to figure out what that would be. And so we're really looking at how far down we're going. So I start with my mean. So this is going to start with my mean for this data. Now remember, we're looking at the data of the improvement. My mean is up here. So I click that cell. And then because I'm looking at the lower bound, I'm going to lower it minus my standard deviation. So I'm taking away standard deviation. And that's because I'm creating a lower bound. When I do the upper bound, I will do addition. So again, I'm going to go here. I'm going to do equal. I'm going to go back to my mean, and I could type these in. And this time I'm going to put plus. And again, I'm going to hit my standard deviation. And we haven't actually talked about these yet, but it's interesting to note that these are very close to these values. That one's not showing up right. I want that to be a number. I want both of those to be a number. Okay. So they are very close. And we haven't talked about the empirical rule yet, but we will. So that's pretty neat. And that's really, as far as the calculation goes, that's it. Though I do want to talk a little bit about this and what this means. Okay, what this means. This means that 68% of my, oh, what was it? 117 wells So 68% of my 117 wells improved between 15, um, 15 and 4 E. coli per well, right? So somewhere in there, they all improved approximately anywhere between 4 or between 15 and 4 E. coli. Um, that's good. That means we've cleaned up these wells. That's kind of the idea. 68% of the wells got cleaned up. Does it mean every well got cleaned up? No, no. Some of these might be positive. They certainly could be. Here we go. I just lucked into finding one. This well right here is positive. It got worse. But we know that 68% of the wells improved. So a couple of things happen here. One, I need to know what, and this is really, we say 68%, but this is really 68.27. That's fine. If you could either do 68 or you could do the 68.27. So what does that equal? So what is 68, what is 117 times 0.6827, right? And that would be, we're going to round it to the nearest well. So that would be 80. So I would then come here and I would say, because I'm not going to put a part of a well, about 80 wells showed okay, so now we have to make a decision. For me, for my data values, this is a decrease in E. coli, which means it's a reduction. If these numbers had been positive, there would be an increase, all right? But they're not, they're negative. So this means, as we mentioned from this first page, right? This is from this first page where they're talking about this. This means that there are fewer E. coli than there were before the treatment. So this says that there's a reduction. So I'm going to use the word reduction. Okay. Between, and again, I'm just filling it word for word what it says. The lower bound, which in my case was 15.78. And you could put the negative if you want. I don't really, I'm not too picky about that. And the upper bound, which in my case was 4.15, E. coli per milliliter. Okay. And then period that, right? Put a period at the end of your sentence. So there we go. I've answered that. And from that, I can really answer the next one. And I'm not going to answer that for you, but it says, what if anything do your calculations in part 4 tell you about the effectiveness of your treatments on the well? Well, obviously my treatment, and again, it's randomized based on name, but mine was successful. I see some improvement. I don't see drastic improvement. We're talking about things that had on average, what was it? Almost 30 E. coli on average. And I have pulled them down anywhere, 68% of them I've pulled down between 4 and 15, almost 16 E. coli. So that's good. It doesn't mean I didn't pull down more. Some got pulled down more, some got pulled down less. But I pulled them down a good chunk of E. coli. This treatment might be improved by increasing the antibiotic, all this other stuff. I could make some judgments. But right now, we're just answering based on this. And one of the things you want to justify your answer using your upper and lower limits, which you have right here. And Also, about how many wells are expected to see improvements within this range. So we've already done that. So that was 80. So we've already given the answer to this, but we're going to be a little bit more detailed, talking about how successful this might be in this last one, but using the information we just have here. Okay. Uh, that is it. And I think that sets you up pretty well to finish this. I know there was no video on this, but sometimes not having a video is to your benefit, so you guys can explore a little bit. I think some of the other ones won't have videos either. So yeah, keep practicing. All right. Have a where's the get rid of button? There we go.